Okay, I think it should be working now. Yeah, let me not have that on the side. Yeah, so it's the ninth day of this Advent calendar. I haven't looked at it, and I have seen some people talking about decks in the IRC channel. So I'm kind of curious about what this one will be. I'm also super tired today. So if I do something really dumb, you know why. Day 9, encoding error. With your neighbor happily enjoying their video game, you turn your attention to an open data port on a little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paperclips. Upon connection, the port outputs a series of numbers, your puzzle input. The data appears to be encrypted with the Exchange Masking Addition System, Christmas, which conveniently for you is an old cipher with an important weakness. Hold on, let me zoom this in for you. Let's also, before we start, just make this bigger before I forget. Let's see. Christmas starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. The two numbers will have different values, and there might be more than one such pair. Okay. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of two of those numbers. So 26 would be a valid next number, as it could be 1 plus 25, or many other pairs like 2 plus 24. 49 would be a valid number, as it is the sum of 24 and 25. 100 will not be valid. No two of the previous 25 numbers sum to 100. 50 would also not be a valid number. Although 25 appears in the previous 25 numbers, the two numbers in the pair must be different. Suppose the 26th number is 45, which is a valid number. And the first number, no longer an option as it is more than 25 numbers ago, was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 through 19, 21 through 25, or 45 that add up to it. So the numbers were 20 and then this sequence. 26 would still be a valid next number, as 1 and 25 are still within the previous 25. 65 would not be valid, as no two of the available numbers sum to it. 64 and 66 would both be valid, because we could plus this onto 19 and 21. Here's a larger example, which only considers the previous 5 numbers, and has a preamble of length 5. So preamble, and this is a valid sum of some of these. Oh god, I'm tired. Between these two, and so on and so forth. In this example, after the 5-number preamble, almost every number is the sum of two of the previous 5. The only number that does not follow this rule is 127. The first step of attacking the weakness in the Christmas data is to find the first number in the list after the preamble, which is not the sum of two of the 25 numbers before it. What is the first number that does not have this property? Okay, so let's first just make a folder here. Go into that. Let me download the puzzle input. Save this in day 9. Input.text. It's good. Okay, so I think I see what people were doing with the deck. I'm gonna do something slightly different, at least for part 1. we might need to go to a deck for part 2. So for, let's see, just for the line in lines of our input, let the number, actually, let's do the old executils, stereotils. Let's do the same old trick that we've been doing. Convert this iterator to a sequence, and let's just map parse int over it. So now we have a list of numbers instead. Actually, let's sort this or store this as a list there. And let's go through for I num in numbers. So I will be our position. We are gonna have to start at position 25. Position 25, that would be, yeah, that would be the 26th number. Yeah, it is a bit annoying that you can't do lines.toSec.mapIt. That has annoyed me as well. I guess that's one of the weaknesses of the UFC. Or UFCS. Right. I think I'll actually do this instead, because we don't want to make a new slice. Like, we don't want, when you do this, you basically make a copy of the sequence. We don't want to do that. And now also I will start at the number 25 instead of the number instead of 0, which would mean we would have to add 25. And now we need to check for, let's just say I in I minus 25 all the way up to but not including I. So this would start at 25, this would then start at 0, loop all the way through. We need to check if any of the numbers sum to this. So let's just call this left, let's call this right. We are going to go from left to smaller than I. Actually, this can be I minus 2. There we go. If left was the sum, yeah. Left plus right. We need to let's make a block here, which is the number check. So if it doesn't pass in, if it doesn't break out of this, that means nothing sums to it and we can quit. Oops, I want to echo out this. Left and right, and this should of course be numbers left plus numbers right. If that equals numbers I, then we break out of the number check. So will this work? We start with this, and then we go. Yeah, should actually start this at left plus 1. So we start with this, and that iterates all the way down until the last number, or wait, this was 5, so it will iterate down to this one. Then it will step one further and do this one and continue checking on, but it will never, it won't go back up because we've already checked that combination. So that should be fine. Just to double check, they mentioned in here that it should only be, oh, okay, it's the first, right? But in this one, it's the only. So let's copy this as a test and let our numbers be equal to just this. Split lines, map it, %, and let me just store the preamble size in a variable so we can more easily change that. There we go. So this should now output the one number from their example, 127, which is correct. Now we have a pretty good indication that this will work. So we can do this, run this, and we get this number right here. Are the numbers actually that big? Or, oops, that was not what I want to open. I want to open input for day 9. Yes. Because they can only be the sum of numbers, the 25 numbers before them. So they would necessarily grow quite big. That's the right answer. Okay, part 2. Now, today I am going to remember to copy my part 1 over to part 2. Nope. Let's have a look. Part 2. Let's refresh so that it can find it. Part 2. The final step in breaking the Christmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list, which sum to the individual number from step 1. Okay. Again, consider the above example. In this list, adding up all of the numbers from 15 through 40 produces the invalid number from step 1. Of course, the contiguous set of numbers in your actual list might be longer. Right, so we need to find a sequence of numbers that sum up to the invalid number. To find the encryption weakness, add together the smallest and largest number in this contiguous range. In this example, these are 15 and 47. Smallest and largest as in numbers. Producing 62. Right. Okay, so we can actually... oh, it was actually only 1 in this set. It wasn't totally clear on that. Because here... did it specify that? Almost every number, the only number is to find the first number in the list. So it could theoretically be more than 1. But let us define our weakness as this. Let's just weakness is just an int. Let's put this in a block as well. Thus breaking here would, like here, would break out of the block, right? Not the for loop. just do that. And break out of the find weakness loop. I mean, I could do this as a function as well, but that's probably a more typical way of doing this. Okay, so continuous set of at least two numbers. So we must start by creating a start and a stop value variable, and then do we need to create those? We could do for I in 0 dot dot numbers dot high, for j in 0, or let's just actually give these some better names. Start and stop numbers dot high. This can be that. So these will now just loop through all of the numbers, and our sum, this should go from start, actually it should go from start plus 1. Sum is equal to 0. Sum should be plus equal numbers stop. This should of course not be 0, it should be numbers start. If sum is greater than the weakness, then we break out of this loop, which means, so if we loop down, it was bigger, then it will break out of that loop and go out to a new start position. If sum is equal to the weakness, then we quit, but we also need to find, so for I in start dot dot stop, we need to find the largest, which needs to start at 0, and the smallest, which starts at int dot high. If numbers I is smaller than smallest, or actually let's just write this in a slightly functional style. Numbers I and, well, not really functional, but and largest, of course the maximum and the largest, and then we need to echo out smallest. What was the smallest times the largest? No, add together. Okay, smallest plus the largest. There we go. So it's bigger, it breaks out. If it's equal, it does all of that. If it's smaller, it will just try summing up. There is a speed thing we can do here. But let's try if this works first. Consider the above examples, that doesn't really matter in this case. Let's see. Oops, that's the wrong symbol. Let the numbers again be this input. Split it into lines and map the parseInt thing over it again. This should have to be split lines, of course, and not splin lines. Nope. Didn't find anything apparently. inconvenient. So what should have happened here was that start should have gotten to 2. So let's just echo out the weakness. Make sure that's correct. The weakness is wrong. Because we didn't update the preamble. Right. There we go. 127 and 62, which is what we were expecting. So now we can change, just don't up that. We can change the preamble back to be 25, and we can remove the test input and go back to the actual input. Run this, and this should be our number. There we go. Okay. So that was today's Advent calendar. So yeah, what I was saying about the speed thing. So we know our number is pretty big. And that would probably be the case for most input sets. So there's no need to start like at the beginning, I think. Actually, what is start and stop for our input set? Yeah, they're quite far down the list. What actually is this one? $610. Yeah, so it would probably be faster to sort of loop the other way around. So start at the weakness and then sort of work our way upwards instead of starting at the top and working our way downwards. But I mean, it's not super slow, and we're really not doing this for optimizing anything. If we compile with release and the arc, let's see how fast this is. Yeah. What is that, 2 milliseconds? Yeah, 2 milliseconds. So it's not terribly slow. As by no means fast. I mean, this, what is this, a triple loop? Double loop. And a smaller loop. So yeah, it's not a great solution, but it works. I sort of forgot to remember the, I forgot to look at the chat. Always do the same. You can just do map parsent as well. Can you? But so the whole map thing, map and map it, there's like some stuff just doesn't work with just map. So I just always do map it, because then I don't have to think about it. Yeah, I already did part 1. I mean, that was pretty quick. Yeah, blocks. I mean, blocks, I really like the whole like naming blocks and being able to jump out of them. I mean, in this case, this should really just have been a procedure. Like this should really just have been like proc find weakness, something like this, and then we could just return the weakness here. Do something like this, and then we could say that weakness is equal to find weakness. mean, this would do the same thing. But I mean, why make a procedure when we're only using it once? You know. 13 lines. So yeah, I like using blocks, especially for stuff like this, like number check here. So breaking out of this double loop instead of having to do something like, oh yeah, I found it, set, like have a variable here, like found is false and like found is true and if found break, something like this. I mean, this would do the same thing. But I just well, okay, now we have some weirdness going on there. That wouldn't work. But you get the point. Like I like this style of like oh yeah, no, that would have worked. Yeah. Because it's like not found thing. Yeah. Wait, does this still work? That indentation looked weird. I'm so tired, I forgot what this was doing already. Left and right, if the numbers sum up. Ah, right, because we're looking for the one that isn't, right? 13 lines for part 2. Down to here. Ooh. That's I mean, sure. You could do some like if you do it in a more functional style where you like just chain stuff forever. Lines can be pretty short. In before overflow. What kind of overflow were you expecting? I mean, this wouldn't overflow. Let's see. Let's have a look at your solution here. I have to go pretty soon. Let's see. Yeah, so you're using dex and int sets. Let's zoom in on this. Dex and int sets. So dex, for those who don't know, is a double-ended queue. So it's a data structure where you can like move both of the ends around. So what do you do here? You call, yeah, you map it to ints, same as I do. The target, solve part 1. And you pass in the sequence. Sure, that's fine. And you turn window into an int set of the numbers. And then you exclude the last one and include this one. And you call toSum. This is an overcomplicated way of doing it. Yeah, so you check if the number in the set is in the, like the remainder is in the set. I mean, this is also a loop, so it does the same thing. It's not any faster. Yeah, okay. And then solve part 2, you pass in the target. Oh wow, this editor really doesn't like being zoomed in. Those highlights are not very good. Solve part 2 to get the 0th element of numbers and as the sum and 0 as the start value. I mean, this isn't. What are you doing here? You're immediately unpacking it. So why don't you just have this on 2 lines? Or 3 as a block? I mean, I guess it saves space, but come on. For I in, yeah, so iterate over all the numbers except except the first one because you have that up there. Well, the sum is larger than the target. Wait, while the sum is larger than the target, and start is smaller than I minus 1, you decrease the sum, basically moving your downwards, and increase the start. Right, okay, I guess that makes sense. And if the sum is equal, yeah, so you keep a, instead of what I'm doing here, where I calculate the sum, like if it's bigger, I just break out of this, and I start calculating the sum over again from the beginning. You basically keep a running sum. That's pretty clever. If the sum is equal to the target, then yeah, then you basically do the min-max. But you would create a slice. Oh, does this work? Min-max for, because this creates a new sequence, right? Huh. I didn't know min and max were defined over sequences. That's pretty cool. Yeah, I see you removed the import. Yeah. As long as t has smaller than overload. Oh, okay, cool. If I is smaller, so yeah, this is basically what I'm doing with this, all of this logic. You're basically doing in 2 lines here. Again, this highlighting. Oh my god. Yeah, that's pretty nice. I like that. I mean, you do create a slice, which is I guess you could, yeah. And if I is smaller than the length of numbers, which, wait, what? Why are you iterating to nums.length, not nums.high? I mean, this should return you way before you get to the end anyway, so you won't, like, it won't make any difference. But I mean, this, you can remove this check and just go to high. That's one thing about these is that they don't, like, they check that you find the correct solution, but they don't check that you have proper error checking. So for example, we could theoretically here say that we want to iterate to twice the length of the array, but that wouldn't be an issue because with our data set we know that we have this end condition, but there isn't, like, if it wasn't this, then we wouldn't, like, we have an error in our code, but it doesn't matter when the inputs were given. That's one thing with the advent of code that is kind of like, yeah, I try to make mine sort of as correct computationally as I can. But yeah, no, I really like this, the min-max slicing part. This inset, I think it's a bit over engineered, to be honest. But I like this running sum, and it's way prettier than what I'm doing here. I mean, mine is shorter. It's basically like this for the check and this for. But I like the running something. I mean, what you could do, could do this, and do sum minus equals numbers start. Just time this by 2. Oop. 0. That would break out of there, then it would take the sum out, and we could then start this at wherever this broke off from. So we would do I hate naming variables. Such a pain in the ass. So go from there, and then s is equal to stop. Yeah. No. I'm too tired. It should be possible to do something like that. But yeah, anyways, that's my my day 1 or day 9 AoC part 1 and 2. I'm gonna upload this to GitHub so you can play around with it. There we go. But it is ON3, isn't it? Because you're doing like this does a loop, I'm pretty sure. Oh no, wait, it wouldn't. Yeah. Wait, what is an int set? Is that basically just a like a set that, yeah, right, yeah. Okay, so yeah, that was my advent of code. Hopefully I'll be able to stream tomorrow as well. Guess this is kind of fun. Okay. See you guys.